Okay, and so now we're on problem 2, tac 31, and I'm just looking at it and noticing that, man, I don't like when they do this. They make it like 5 or 4-part questions. It's one question, make it one part. This is like when someone says, well, are there any questions? And you raise your hand and you say, yeah, I've got one question, but it has 7 parts. Well, that's 7 questions. All right. So let's just do this one and then we'll call it a day because this one's got a lot of parts and actually like 1 or 2 of them look a little bit tricky. But okay, so determine whether or not the triangles in each pair are congruent. Justify your conclusion with a triangle congruence theorem. Okay, so now you gotta, let me see. Actually, maybe I can use this thing. I haven't tried this one yet. Well, that wasn't what I wanted. All right, so let's try there. And then can I go from there to there? And then from there to there, and from there to there, and then from there to there. Huh, that worked out a little better. All right, and then let's go from there to there, and from there to there for our right angle, and there to there, and there to there. It's not exactly straight, but all right. So now, what do I want now? So now I want the scribbly thing so that I can write some numbers. So there's an 8. And we got a 4 down here. And then we got a 6 over here. And we got another 8. Okay. Whew. I'm getting pretty decent at this. Alright. So, they want us to know whether they're congruent. So let's see. So this side is definitely equal to this side because they're both 8. So that's kind of cool. So actually, we have side. We know this is 90. And then we have side. But actually, we don't even really need to do that, do we? Because we have, what is it? Well, we don't have the hypotenuse yet. I guess that's part of the problem. So we know that if there's a 90-degree angle, and we have, so it's a right triangle, so what's the one that we could use? We could use, what is it, hypotenuse length, right? But that means that we need to know the length of the hypotenuse, and I think one of the sides, right? Isn't that how that works? So let's look up hypotenuse length theorem. Oh, man. And they got rid of my internet. Okay, well that stinks. So let's see if I can complete this without internet. So I think we need the length of this hypotenuse right here, and then we know that this one is 10, right? So we know that this is 10 in total. 10 in total, because we can add 6 plus 4. So we really need to know what this one is. So here we know that this one is 6. So if this one is 6, then we're good. So we've got 8 and we've got 10. All right, so let's go see if we can figure this out. So let's do a new equation. And we've got, so we know that A, let's see, how do I do this here? A, there we go, squared, whoops, that didn't do it. Let's try that again. If we do A squared plus B squared must equal C squared, right? And so in this case, we've got 8. Well, we can do 8 and 6 right here. So let's do 8 and 6. So we know 8 and then over here, we've got 6 equals something squared. All right, so let's figure that out. So 8 times 8 is 64. 6 times 6, 36, equals, and what is that? That is 100. But, so I guess we could do this way. Hold on. Let's do equals C squared. So then we know that 100 equals C squared. And so now we want to take the square root of this one. Boink. And that means we need to take the square root of this one. Boink. All right, so the square root of C squared well, I guess we won't get into it. But this could be 10 or negative 10. So usually the way they write that is right there, equals C. So, and that's because negative 10 squared is also 100, but 10 squared is 100. Now, That's just the like correct answer for the algebra, but for geometry, you're not going to have a negative length side, so we know it's just 10. But when you get a little bit farther, they're probably going to ask, like, the square root of 100 is plus or minus 10, because it could be negative 10 or positive 10. But in any case, so we know that C is 10, so that means that this is 10. And now we know that, so 8, 6, 10, 8, and so this must be 6. 8, 6, 10. So we could use a couple different theorems. So we could even do side, side, side. We could do side, angle, side, side, angle, side. Or we could do hypotenuse length. So I don't know if that just means that it's a 90-degree angle and then the length of the hypotenuse, or whether you need one of the sides and the hypotenuse. And my internet's still not working too well. So I don't know. But either of those works also, because we just did the math. So yes, those are congruent. So for A, they are congruent. So now let's look at B. So let me remove that one. So now let's look at B. So kind of got to rotate this thing. But it looks like these two angles are equal. These two angles are equal, which means that this third angle must be equal, right? So let's see. So let me just go ahead and, do I really need to draw? I'll draw it just for, it should go pretty fast. Okay, there's that one. There's that one. And then I'm going to do the scribble. So we've got that one, that one, that one, that one. So we know this side is equal to that side. So that's cool. We know this angle is equal to that angle. And we know this one is equal to this one. So that really means, because if this and this are equal to this and this, then this one has got to be equal to this one. So we know that all the angles are equal. But since you can't have all angles equal, and that doesn't prove congruence by itself, all angles being equal, because it could be just a bigger version of that triangle. It doesn't mean they're congruent, right? Like if I just have like a huge version of this triangle, you know, where I make all of the angles equal, but I just enlarge the size of the triangle, then all the angles are still equal, but the sides are no longer equal. Like this one's like twice the length of that one. But that's for that triangle. But okay, so we have all these angles are equal, but look, we have angle, side, angle, and we have side, angle, angle. So you could use either one of those to say it. So I think we can do side, angle, angle. Should be fine. So I think that's what is that? Side, angle, angle. Is that right? I think that's one of them. Boink. But you could check if you just if you have internet, you could search for triangle theorems. But I think that's one of them. So those two are congruent. All right. Whoops. Okay. So now let's do C. Oh man. All right. Oh, let's do my lines. Let's see. So we'll go there, and then there, and then there, and then we have a kind of a bisection like right there, and that one is equal to that one, and whoops, and then I need my scribbler. Where's my scribble? Scribble! Scribble, I say. Alright, we got that, and that one is equal to that one. Okay, so what do we know? Well, we don't know that those are 90 degrees. We know that those two sides are equal, but we know that these two sides are equal. So I guess we could write that. But unfortunately, I don't think that this necessarily tells us. So we've got, well, we have side, so we have side, side, angle, but this side isn't the same side, right? Like that's kind of, if I rotate this one, like if I take this triangle right here and rotate it, what do I get? I get like, if I rotate it, get, what do I get? I get 3 on this side, right? Because that's that one. I get 2 on this side, and then I get this angle. So they're not exactly the same, right? It's like this angle should be, or this side right here should be like 2, and this should be 3 for them to be really equal. And then I don't know that we have enough information for this one. Let's see what their answer is. Do the tick marks prove the triangles are congruent, or is more information needed? They are not necessarily congruent. There is no such thing as side-side angle. Okay, well, there we go. Yeah. So, yeah, we have side angle, but even then, they're not the same sides. So, all right. Yep. So I guess one of the things to learn, to remember here is to make sure you know your angle theorems, and I guess that's why they talk about having a theorem graphic organizer. So maybe they just mean that that's just a sheet of notes that tells you which of the possible things that you can use, which angle theorems you have. So like side, 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 side angle, 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 side angle, and a couple other things. Okay, so let's go look at D. Let's get rid of this one. And let's look at D. All right, so let me draw this one out real quick. Bam. And then bam. Bam. Boom. Bam. All right. And then I'm do my scribbling. So we got this angle is equal to that angle. Okay, that's odd. And then this side is equal to that side. And then we know this side must be equal to itself. Okay. Oh man. Let's see. Well, we have sine angle side. Do we have side angle side over here? Because we have a 2 tick mark, a 1 tick mark, and a 1 tick mark. And then over here we have a 2 tick mark, a 1 tick mark, and a 2 tick mark. I think so. Like if I take this triangle and I rotate it, like if I flip it, I think it's going to look like, yeah, it's going to look exactly the same as the other one. Like that. Man, that's terrible. Yeah, I think so, because well, let's just make it a little bit, let's make that a 3, like that a 2, and that a 2, and let's just see. So if I go hypotenuse, or not hypotenuse because it's not a right angle, but if I go the long side, angle, short side, then it's 3, 2, 1. So if I go long side, angle, short side, it's 3, 2, 1. Yeah, so then by side, angle, side, boink, we got it. They are congruent. Okay, and that's it. Man, that was a long one. Okay, that's probably enough for today. Anyways, I hope this was helpful. Hope you had a little bit of fun. Hopefully it's getting easier. It wasn't too hard. Wasn't too painful. And have a great rest of your evening. And I will talk with you guys again soon. All right, good night.